Streaming. We'll refresh my screen here. Hello, people of the internet. We have Haley joining us. In case we are streaming, I'll introduce her. Haley is a friend and colleague of mine. She joined me for an offline session, re-recording the beauty that was how to create a Bitcoin trading bot the last couple hours. We'll be on until 1 o'clock in the morning, aside from different breaks that we each have to take during the course of the live streams. We'll be doing 4 live streams today. And let's just see if Peter can see us streaming. Are we in the right live stream? Yep, how to build a dApp on Ethereum. And we're streaming. Everything is fine. Guys, on this live stream, Haley and I are going to walk through how to create a decentralized application on Ethereum. And all that means really is that we're going to build an interface for a smart contract, and the one we're going to use for this particular contract in question is going to be a voting contract, which is one of the basic functions of Ethereum and most blockchains. The idea is that things can be democratic and people can vote on what they want out of different outcomes. In our case, we'll have candidates, just as an example. We won't even really name them. We'll just vote on something using different Ethereum functions. That said, we'll build an interface using JavaScript around our smart contract function, and then we'll be done. This is going to take the course of the next 3 days. So that's today, the 24th of September, and then the 25th of September, and then the 26th of September. And we'll build an Ethereum smart contract. Let's take a look at the overview with the curriculum. Actually, first we're going to set up the environment. We're going to talk a little bit about what ETH contract is, what are different blockchain interfaces, talk about having a synced ETH blockchain to do our testing and interface with our MetaMask to build and deliver our Truffle.js contracts. Then in the next session here, in this first section, we'll talk about what Truffle.js is specifically, what it does, what it doesn't do, how it helps, what it's supposed to be used for, and install other dependencies we need to get our code up and running on top of my base template of having this Windows VM running Node and a whole bunch of other stuff. We were doing another project here earlier, but we can actually stop doing that for now. What I do want to show you right here in this session is the fact that I have Go Ethereum syncing to the rinkeby test net, meaning that we can use fake funds to do everything we want to do, including publish our contract and interact with it. And we're going to use a couple other calls here, like sync mode. So sync mode is important. It's how the blockchain syncs from your client, which in our case is geth, to the blockchain. There's a bunch of different ways to sync, and they each take different amounts of time and do different things. In regular mode, you sync every part of the blockchain, including all the transactions and everything that happened in that block over the course of the entire blockchain, which is a whole bunch of different blocks. It's different for each different kind of testnet or live net that you try to sync. But for us, we're going to sync using light mode. There's also fast mode. The difference between fast mode and light mode is that in fast mode, you're going to go ahead and sync everything up until the last 64 blocks. You're just going to do the bare minimum, and then for the last 64 blocks, you're going to sync everything that there is. What this happens to me on my slow connection is it goes ahead and it syncs up until the last 64 blocks, and then it never syncs the last 64 blocks, which is not good because we can't use that. Now, I did figure out why this wasn't working here before. My geth attach function. I wonder if we can figure that out again. It's right here. So what I want to see is if my blockchain is actually synced. So I'm going to run eth.syncing. And it's actually false, which means that it has synced. All 3 million blocks or whatever are synced up into our local data store here using the light sync method. Basically, that's just the one we want to use if we don't have a very fast internet connection and we just want to interact with the blockchain locally without syncing the entire blockchain, which takes a very long amount of time. Any questions so far there, Haley?
So just to go over what you said, basically, the light sync mode is all of it?
Nope, light sync mode is the very, very bare minimum that you need, including like the least amount of data, and it takes the least amount of time. Nope, the fast sync is when you do everything, and then you do everything in the bare minimum, and then for the most recent 64 blocks, or the most recent amount of time, it tries to sync the full thing, including all the transaction logs and everything that happened. And then in light mode, what happens is it doesn't do that. It just does the bare minimum for everything.
Okay.
The next thing we're going to talk about is what is my Ether wallet. and MetaMask and other blockchain interfaces. And I think I've explained this to you, Haley, basically that the different ways you interact with the blockchain are just basically like layers on top of the blockchain in order to do stuff with the blockchain. What that means for our friend Ethereum or Ether is that you can use my Ether wallet, you can use MetaMask, you can use a bunch of different ways to interact with that blockchain. You can use JavaScript, which we'll do in this tutorial, to interact with the blockchain. And it's pretty cool. We have 10 viewers right now there, Haley. Alrighty, that's pretty cool. Alright, what's going on? I want to use my Ether wallet, and what I want to do is I want to go into my Gmail and pull up a contract that I've already published here in the live net previously. We're going to use my Ether wallet to see some of the functions on that contract. You could also use Etherscan or a plethora of other open source sites to do that. But right now what I want to do is, I'm getting a lot of junk now. Anyway, I want to see the multi-sig contract that I published. And actually we're going to be working on a multi-sig contract today in the next live stream to recreate the success that I've had creating this multi-sig contract on the live net, and we're going to be doing it on the test net. In order to access a contract on the blockchain, you're going to need the API or JSON interface, which is just telling your MyEther wallet how to interact with this contract, including all of these functions that we have here. So if you wanted to get information from the blockchain, we're going to use MyEther wallet to interface with the blockchain. We could get something like the transaction count. It's actually going to give me 0 because I haven't really used any transactions on this multi-sig contract. And again, we'll learn more about multi-sig contracts in the next live stream. What's important here is that you can use the blockchain through my Ether wallet or MetaMask or different interfaces to accomplish all the functions that exist on the smart contract. So if I wanted to submit a transaction, I could use my variables here the function requires, like the destination address where I want to send Ether, the value, how much Ether, data, including like if I want to send tokens, the specific function we want to call on that contract, and then I'll unlock my wallet using a private key and pay the gas to do that. We'll talk about gas actually in another live stream that we're going to be doing, I think, on Thursday. We're going to talk about how to look at gas, how to interact with gas and what gas means, and how to see different gas variables on the live net. So LiveNet basically means that Ether has different test nets, like testing environments that we can use fake funds on, and that it was developed on, and we can develop stuff without actually risking any money or using any money. Then the LiveNet is where the real Ether value is, like the ones that cost $200 or whatever it costs now. It lost a lot of value. But do you have any questions, Samar?
The private key is like a password, right?
Yep, the private key is the private key. It's what you keep secret and make sure that nobody has access to. If they do have access to it, you will lose all of your Ether and all of your tokens and not have access to that wallet anymore. I see it with people joining the stream, so thank you very much for Low Level and CT Francia for joining the chat. If you guys want to say anything, you can say hi. I'll say hi to you. And you can actually follow me or give me a subscribe. We only have one so far. Again, thank you so much to DHD or whatever his name was, 18, whatever it was. He followed me there in my last live stream, and that's our very first follow, so I'm glad to have him on board. We have somebody else joining the room. It's Low Level again. Hey, Low Level. How are you? Okay, so where are we? We want to go back to the curriculum. Next thing we're going to do is talk about how to install and configure and back up MetaMask. We're going to be using MetaMask in order to deploy our Truffle contract today, which is going to be, again, a voting contract. It's just a sample that I found online when I searched how to build a dApp in Ethereum. So what I want to do then is I want to search for MetaMask. Now, MetaMask is a plugin that you can get for Chrome or Firefox. Basically, it allows you to confirm any transaction that you're trying to do with your blockchain interface, which is MetaMask. And you can download and install it. It's going to give you an address. You can import addresses just because it's an interface with the blockchain. An address you create elsewhere is just as good in MetaMask. We're going to create a new one here once we add it to Chrome. And it's going to download and install. So who wants to chat me in the room? That's the question. Does anybody want to chat Haley? Say hi, Haley. Anyway, people haven't chatted before, so I don't think they're going to chat today, but who knows, they might chat today. So hey, MetaMask is installed. We click on the little icon in the task or the notification bar here. Can I please use MetaMask, guys, or are you just going to show me how to use it? My virtual machine is being very slow because I reduced the resources it has a little while ago. Let's close some of these windows, maybe that'll help. Okay, let's try again. We have 18 viewers on our live stream. Oh my gosh. Hi, everybody. So you have to agree to the terms and conditions. It basically says, please don't mess up your funds. Please don't share your private key. All that fun stuff. It's actually going to give us a mnemonic phrase. I think I pronounced that right, which is just a series of words that unlock your wallet. It's like another kind of private key. Every wallet has a private key and a mnemonic phrase and a number of other ways to unlock it. So here's the mnemonic phrase. We're going to save this somewhere safe because it tells us to in case we ever lose our MetaMask and need access to our wallet again. And I don't really care about this wallet. We're just going to be using it on the rinkeby testnet anyway. So I'm just going to save it locally where I can't save it apparently because I don't have permissions. And then it's going to say, have you copied this somewhere safe? And I have. Here's my account in MetaMask. I can do lots of different stuff here. I can copy my address to the clipboard. I can see the account on Etherscan. But what's really important is that we can change the Ether network that we're using. Right now we're on the LiveNet, or main Ethereum network. There's a bunch of test networks we can use here, including Rinkeby, which is the one we're interested in. The next step then would be to actually get some funds into that Rinkeby wallet. We can do that using a faucet. So we just Google Rinkeby faucet. Here's a rinkeby faucet for us. I think that what I need to do is tweet with my Ether address and I gotta log in to do that. And everybody should follow my Twitter. And hello, Igor. I'm glad to see you. I think we've lost a bunch of viewers, but I don't know if my stream has just stopped working. So did I tweet that? Enter social network URL, including your tweet. So let's go to Twitter. I said hi. Nobody said anything. 23 viewers in here. Let's go to my tweets. I think I found it. Now I just need the link or the URL, which is in here somewhere. So I'm just getting fake. Sorry, go ahead. What's that?
Your cover picture on Twitter, is that Gotti?
Gotti and Beanie, yeah.
Cute.
Yeah, that's when they were young. So right now it's giving me 18 whole Rinkeby ethers to test my my Truffle.js functions, or for contracts rather, to deploy them and interact with them using my address, which is exactly what I need. I just need some Rinkeby ethers to do that testing, and that's free. That's free for everybody. You can do that once every 3 days on this particular faucet. Get 18 free ethers to use on Rinkeby, which is awesome, really. So right now it's funding. I mean, I should have my ether here soon, if not already. I do have my ether. Look at that. I have 18 ether. Guess what? It's worth $4,384. Not really. That's if it was real ether. So that's great. Now I have some test funds. Do you see that? See that? Look at that. That's a lot of money. That's not real money, but it'd be cool if it was. Now, I guess that's that. What else do we have here in the deliverables for this section, or session rather? That's it, actually. The next session we're going to cover Truffle.js. Actually, to tell you the truth, we're going to combine that with this session since this one is not that long. We're only on for 13 minutes, 14 minutes so far. So if I was to edit my session list, or my curriculum rather, and throw this one in with this one, we could go ahead and talk about Truffle.js and other dependencies that we have. So we're actually using a very specific guideline or tutorial that we're covering, which I actually found by Googling how to build a dApp on Ethereum. Whoops. So we'll go ahead and which one was it that I wanted to do? Here it is. It's going to give us a whole introduction. We've already done an introduction. Basically, the dApp is going to interact with the JavaScript in order to go ahead and deliver an interface for our smart contract that we're going to use MetaMask to unlock our wallet to do stuff with. That's how it works. It's just an interface on top of an interface that interacts with the blockchain. So we have Node installed. We have npm, which is Node Package Manager installed. What we want to do then is we want to create a folder inside the root of my C drive for this project. we're going to call it voting contract. We're going to go ahead and go into that folder inside of the command prompt. Do you have any questions, by the way? Oops. We're going to install Truffle in this folder using the Node Package Manager, which is just basically a way to grab different libraries off the internet when you want to use them. So Truffle is actually a library for building and deploying and configuring and testing Ethereum smart contracts. So basically, with Truffle, you don't have to use Solidity anymore, which is the old way of doing it. And you can actually just use this package library, which includes a whole bunch of different functions that Solidity doesn't really have, like asserting your tests and making sure that everything works the way you expect it to before you deploy to the test net or labnet. I guess it wants us to install Ganache, but we don't really need to, or Ganache. I don't know what it is, because we already have our rinkeby testnet synced with 18 Ether. It says to install MetaMask, so we actually have MetaMask, and it says syntax highlighting, but that's fine because we have Notepad++ here, and we actually described this in our last live stream that the Notepad++ is going to highlight our functions and all that fun stuff with syntax highlighting. So if I have a test function like this, and then I save it as a JS file or a JavaScript file, like app.js, just for simplicity's sake, it's going to highlight this stuff with useful colors when there's different keywords or numbers or anything that it wants to highlight for us. That's what it's telling us to do. So here we go. We're gonna clone an existing Truffle application here into our voting contract folder using this unbox command for Truffle. So basically, Truffle is also a service that exists to help our lives, make it easier, make it learning easier, and includes a whole bunch of pre-built packages and example contracts for us to use. That being said, I'm unboxing this pet shop project right now, which is going to give us all the files, all the migrations, all the code that we need to work through to get our voting contract up and running. So now that we have Truffle installed, we can call Truffle as a command inside our command prompt and get it to work. So it's taking a couple seconds here. I don't know if setting up means that it has everything in the folder or what. Oops. We can actually open the folder as a workspace using our trusty Notepad++ here, or Sublime Text in Linux. So I actually do have all the files that I'm looking for, including a test folder, a source folder, a migrations folder, a contracts folder. Oh my gosh, look at all this stuff. So it looks like the source is going to be our decentralized application because it's got HTML files in there. The migrations folder has a migrations JavaScript file for us to be able to run the contracts through the steps that they need in order to publish the contract. So if we have a multi-step contract, like if we were to look to build a token contract as well as a crowd sale contract, it would go through all those migrations and publish them in order with the variables they need to make each other work, which is great. That's what Truffle's for, is to make our lives easier when we're creating Ethereum contracts. So there's actually no contracts in our sample code. There's a migrations.sol, which basically runs these migrations and as a smart contract inside Truffle. But what we're looking to do then is create a folder called election.sol inside the contracts folder. So I could actually do that in Windows Explorer. Whoops. So here's where we're gonna put our smart contract code inside of this Solidity file inside of Truffle's folder that it gave us. Now I can't change an extension in my Windows commander view here unless I uncheck, or rather check the box that says view file name extensions, which means I can change the extension from txt to something else, and then in our case it's going to be elections.sol. And then we're going to open that file inside of Notepad++. We actually don't need app.js anymore at all, so we can probably delete that. Is it still in here? Nope. And here's the start of our code. So what we're telling it here in this code is that we want to use this version of Solidity to build the code. So Solidity comes out with new versions all the time and increases the amount of features and changes bugs and fixes security flaws. But we want to use 0.4.2 for this example. The contract is going to be called election. That's what a contract is called because that's what it does. As a variable, it's going to store as a string, which is just a series of letters and numbers. It's going to store the candidate variable. And it's going to be publicly available, which means people on the blockchain can see that and interact with that. Inside the constructor function, which is just called the same thing as the contract, and it's run when the contract is built, it's going to go ahead and create the candidate variable. It's going to call him candidate 1. That's all that we just did with this code. So now we need a deploy contracts migrations file. So we'll go back to our folder structure. I copied the name of the file that we need. We're going to create a new file, call them this. And we're going to throw in our code. Now our code here is telling the migration that's running to load our election.sol file. It's going to go ahead and, let's see what our live stream is doing if I refresh the page. It's going to go ahead and deploy that election contract. That's all that's doing. It's telling Truffle how to do his job. It's going to go ahead and deploy that contract to whatever testnet or livenet we agree on. Now, I think that we're going to have to change our Truffle.js file, actually, in a couple different ways. We might need to add a from address, or the address that we're looking to publish from. Now, I actually don't have an address on my geth yet. So if I was to do geth, oh no, I got to do geth this to attach. So in here somewhere I can create an address with no, actually, because I want to
So what are you trying to do?
Right now I'm trying to get my address that I just got 18 Ether on in MetaMask into geth so that we can use it using the code to publish the contract. So let's figure out how to import actually I can export the private key here through MetaMask. Come on, address. If I was to export the private key and input my password to do that. So yeah, when we go to deploy the contract, we need gas to cover the price of deploying the contract, like the fee. So import account geth, if I just search that, we can figure out how to get an account in here from MetaMask. Again, they're just different interfaces to the blockchain. So open Notepad, place key into the Notepad. Whoops. Control N, please. There we go. pk.pk or whatever. pk.txt works. Save the file. Run the command geth import. Geth account import. So right now we're just getting this account into geth so that we can use it. Actually, I need to be outside of geth to do this command. I gotta set a password for it. And there we go. So I think what I was talking about here in the code is that we got to tell geth that we want to use this address. So I think we got to set the from address to be our address here that we have inside MetaMask.
Is that in Truffle?
This is Truffle, yeah. This is the configuration file for Truffle that tells it what to do. Now we're also going to need to make sure that this account is unlocked, meaning we have to run the attach command here. And we have to do eth dot, I have no idea what it is actually. Unlock, let's Google it. Unlock account geth. So right now the account is locked, meaning that nobody can initiate transactions using geth. So we have to run a command inside geth or inside our code. Actually, we can do it that way, but I'm not sure how. I think we would need to add the account to the personal account, all that fun stuff. Really what we want to do is apparently this. So if I was to do this the right way, it's probably going to do my password in plain text. So please, people don't hack me because that's my password for everything, which you're aware of anyway. So I want to unlock my Ether address. No, it doesn't want to do that because it's not. It's trying to attach to a livenet geth. So we have to use this other way to do it. which apparently I can't hit the up arrow key to copy or to re-command. Okay, personal. Whoa, it copied a bunch of times. Okay, so again, we're going to have to put my password in plain text. That's okay. And our address is going to be... And this is just allowing us to do transactions on this address using geth. No key for a given address or file. I don't know what that means. Do you have questions right now?
Not really, kind of.
Okay.
Right now, I'm looking for a key for.
Right now, I'm trying. Right now, I'm trying to unlock my my account, but apparently I need to import the account again because my first import didn't work. So I'll do that right now. Now again, never share your private key with people. And this is just a technical difficulty because I'm not really used to using geth that much. But I know it's possible, so I'm just Googling what I need to do and figuring it out. So I just imported that private key, and now I'm going to try and unlock that account again. But I have to do this.
See, I was confused because I knew you knew your private key.
Yeah. No, it just didn't work with the first import that I did. So the second import that I did, which is import raw key, apparently did work. I don't know if it's a conflicting version of geth or whatever that didn't import it the first time. But the second thing that we tried worked because I was able to unlock that account. So now we can run our Truffle.js and to get it to publish this contract when we're ready. That said, what is our learning objective here? Code, and then testing, and then client-side application. So we're actually going to change this around a little bit. We're going to add code testing plus deployment is going to be our next session. This session has currently lasted 27 minutes. Congratulations, everyone, on lasting this long. We have 41 viewers in the live stream. So where are we now? List candidates for voting. So we're still listing candidates for voting. Somewhere on here I had my guide. We're going to migrate. Then we're going to Truffle console. What is this? Now that we're inside the console, let's get an instance of a deployed contract and see if we can read the candidate's name of the contract. Okay. So we're going to run our Truffle stuff. We're going to create this. Oh, look at this. Module is undefined. Oh no. Truffle. We got issues. We got issues. Truffle migrate module is undefined. Can't compile. Can't compile, man. Can't compile, man. Just wanted to check. I am having the same issue. Quick tweak. Find the truffle.cmd. Copy the file and rename it. Use truff compile. Ah, that's dumb. So apparently it's trying. Windows is just doing something dumb that Windows does. I've never had this problem before, but if I go into npm here and find truffle.cmd, if I rename this to truff, it's going to work the way we expect. Which is not something you have to do in Linux, and not something I've ever had to do in good old Windows before, but apparently it's working right now because it's thinking about it. It's deploying our contract. Something I broke here. Defining constructors as, what did I do? Looks like our sample code is broken. So apparently you can define a constructor using this version of Truffle inside of our code, wherever it was, using the same name as the contract. So if we just change this around and use constructor, like this. So our code is outdated and doesn't work with Truffle, which means we get to have fun little errors as we go along and fix them using the recommendations they give us in the errors. Hopefully this is going to work. Hopefully we're not anything else. No, I broke something. So our version of Solidity, or our compiler, is off compared to the one it's requiring here. So let's just change the requirement to use the one we're using in our compiler. Hopefully that'll work. And it takes a few seconds to load each time. Nope, we broke something. I wonder if we get rid of this in this part here and just use the version number. No, what did I break? Let's see if we can fix this error by Googling it, man. Try to set it to greater than 0.0. What was it originally? So I can actually just set this to greater than, and it should use the one that we have in geth or wherever it's finding the compiler. If I use greater than, it should work, man. That'll use any version greater than the one we're trying to establish, which was less than the one that we have in geth apparently. So it's doing stuff now. Could not connect to your Ethereum client. So what did I break here? In Truffle.js, it's trying to connect to geth. Maybe it's on localhost and a different port. I don't know. Let's try localhost though. Because it is running. It's right here. Maybe I didn't run it with RPC. We'll find out, man. No, it's giving us the same error. Let's see. Did I run you with RPC? Actually, I think it was just stopped in its execution. Which is unfortunate, man, but we'll fix it, man. It's trying to shut down, but it's not actually shutting down. Interrupt more to panic. There we go. It's all broken. It's all sorts of broken. Okay, so where am I? Okay, so our endpoint is up on, it says one localhost should work and 127.0.0.1 should both work. If I try to migrate again, this should be running now. It might not actually be synced though until it tells me that it's importing block headers. We'll find out in a sec. Oh, this is funny because this should be our actual next session. So maybe we'll take a break here while I figure out why this isn't working. And we'll come back and we'll do this as part of the next session. We should be covering how to do this anyway, which is our testing and deployment. We actually haven't run the test yet, but we can run the test. I don't know if there's any tests to find. So we might change testing and deployment to just deployment. Either way, we've done the code for this first session. And the next time we're going to come back and do our testing and deployment. And the code, again, was basically creating the candidate listing inside of our smart contract. And then we're going to go ahead and deploy this contract and then see that candidate listing using the Truffle console as soon as we can get this to work. I don't know why it doesn't see my Truffle. Or my geth, rather. Maybe it's on the wrong port. Who knows? It should tell us in the output here. 8545. It is on the wrong port. So a port, Haley, is basically like a series of different numbers that allow instances on a computer to access the internet. So everything runs on a different port. When you access a website, it's basically always on port 80 or 443. There's different numbers of ports for different things. Basically, you want a free port because you want to be able to use the communication to do stuff. It looks like we're migrating now, so we're going to go ahead and stop migrating, and we're going to come back with a new section to go over migrating and deploying. Okay, so Haley, we're going to take a break. I'm going to leave video on. I'm going to kill this stream. We currently have 48 people watching, which is awesome. If you guys want to subscribe, that'd be great. We have Yura and Hezika. And actually, Hezika said hi. Look at that. Thanks, Hezika. Hi.
Hi.
Hezika. That's the first time I've ever had anybody chat in chat. That's awesome. Sorry I didn't see your message. Let's see if Hezika has any questions. That's cool. I never knew anybody would chat me. That's the very first time somebody's chatting me. I don't know. We'll see if he has anything to say or she has anything to say here in a sec. Otherwise, we'll kill this stream and we'll start a new stream when we go to actually deploy this contract. And then first we should probably test it. I don't know if any tests are defined, but we'll find out here when we come back for the next session. There is a test folder. We just have never created any tests, so it'll obviously pass. What's in here? It looks like Hezika's not going to answer us right away. There's actually no tests, so we're going to rename this next session anyway to just deploy. Well, that's not going to take us 10 minutes though. Well, yeah, well, because we're going to go ahead and see if that lists that candidate using that code that is in the tutorial. So that will take us probably 10 minutes. The minimum for each session, by the way, is 10 minutes. Do you have any questions right now?
We go over what Solidity is again.
Yeah, Solidity is the programming language for Ethereum contracts. So you could actually use the Solidity IDE online, but we're using Truffle instead. Basically, they're just the different interfaces for deploying and publishing contracts to the Ethereum smart blockchain. So you see here, there's a sample contract. That's basically the same kind of thing we're trying to do right now inside this Solidity browser. And basically, Solidity is the language that lets you publish stuff to the blockchain. Truffle and the Solidity IDE, which is this website here, are different ways to build code and deploy it to the blockchain.
Yeah, that was my only real question.
Okay, sounds good. I'm glad you're here. I'm glad you're helping out. I'm glad you have questions. We have 45 viewers in. Somebody left because I said I was going away. We are going away. We'll be back in 3 to 5 minutes after we have a short break.